Bismillahirrahmanirrahim. So in physics, today inshallah we will discuss about the basics of the chapter work power energy. So the first topic that we have is work. Okay. In general sense, anything we are doing, let us say someone is sleeping, okay, we call it work. Someone is sitting, this is work. Someone is walking, someone is running, someone is lifting weight, okay, all work. But according to physics, not everything is work, okay. Like to say that you have done some work, you have to apply a force, and due to the force, there has to be a displacement along the direction of the force application of force. Okay, so two things are required: force and displacement. Let us say you are pushing the wall, you are applying force, but the wall is not moving from its place, so no displacement, so no work. Both has to be there. Okay, so W work is equal to force into displacement. Okay, and force has a unit of Newton and displacement has a unit of meter. So the unit of work is known as Newton meter, but it is also called joule according to the according to the name of a scientist, James Prescott Joule. Okay, according to his name, it has been given joule. It is expressed by J. Now, sometimes for 2 mark, they will ask you question. What do you understand by 50 joule? What do you understand by 50 joule? So we know that 50 joule means 50 joule work. Okay, 50 joule work. So this one only can be achieved if the product of force and displacement is 50. What I said, the product of force applied and the displacement has to be equal to 50. That can be written in many ways. Like if I say that if I have applied 1 Newton force on a particular body, and due to my application of 1 Newton force, it went through a displacement of 50 meter. So 1 into 50, this will give me 50 joule of work. So this is the significance of it. You can write that 50 joule work means uh, if 1 Newton force is applied on the body, it will go through 50 meter displacement. Okay. Or you can give it in a different way. You might say that, okay, I will apply 50 Newton force and it will go through 1 meter displacement. Still, you can say that you have done 50 joule of work. No problem. You can say that you have applied 25 Newton force, and due to this application of force, the body went through a 2 meter displacement in the direction of the force that is applied. Okay, so you can say that you have still done 50 joule of work. So the significance can be written in so many ways. You can choose any one of them. Okay, this is important for 2 mark. Okay, then then we will talk about energy. After work, we will talk about energy, not power. Why? Because work and energy, they both are the same thing. This one I have been telling you for the last 2 years repeatedly, right? Work is equal to energy, energy is equal to work. If I can do 50 joule of work, you can say that I have 50 joule of energy. Or if I say that I have 50 joule energy, then I can do 50 joule of work. একজন মানুষের যতটুকু এনার্জি আছে, সে তার থেকে বেশি কাজ কখনোই করতে পারবে না। একটা বডির মধ্যে যতটুকু এনার্জি জমা আছে, ঠিক সেই পরিমাণ কাজই করতে পারবে। তার থেকে বেশি করবে না, তার থেকে কমও করবে না। কম চাইলেই করতে পারে যে কিছু বডি কিছুটা ওর মধ্যে স্টোর রাখবে। বাট হোয়াট ইজ দ্য ম্যাক্সিমাম? ফুল এনার্জিটাকে যদি ওয়ার্কে কনভার্ট করো, দেন ওয়ার্ক অ্যান্ড এনার্জি দে উইল বি ইকুয়াল টু ইচ আদার। আন্ডারস্টুড? Okay. So always remember, work and energy, they both are the same amount and the units are also same. Work and energy, they both have the same unit. So this is also important for MCQ. During our time, we used to see MCQ like that. Which two of the following have the same unit? Okay, question is which two of the following have the same unit? So option A, they will tell us work and power. Option B, they will tell us power and energy. Option C, work and energy. Option D, none of the above or anything else. Okay, so we know that we have to mark work and energy. They both have the same unit. Okay, please remember. So work and energy, the unit of both of them is joule. Okay, acha. A question that I used to ask you always, that there are two person. One person did 20 joule of work in one day, another one did 20 joule of work in 2 days. So who has higher energy? তোমরা সবাই এটা এখন পারো, তাই না? এটা বারবার জিজ্ঞেস করতে করতে তিতা বানাই ফেলছি মনে হয় সবাই।
জি স্যার।
Who has higher energy?
স্যার both are same.
Both are same. কি বলো ইমন? একজন লোক একটু তাড়াতাড়ি করে ফেললো, তুমিও একটু বলবা না যে ওর বেশি এনার্জি?
স্যার তাড়াতাড়ি করছে তো কি হয়েছে, বাট কাজটা তো সেমই করছে, রাইট?
অ্যামাউন্ট অফ ওয়ার্ক ইজ সেম, সো এনার্জি ইজ সেম। এই কথাটাই মানে অনেকেরই মনে থাকে না। যাই হোক, তো নতুন স্টুডেন্ট যারা আসে তাদেরকে যখন এই সেম কোয়েশ্চেনটা করি না, ওরা অনেক এক্সাইটেড হয়ে আনসার দেয়, স্যার 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 এটা পারি এটা পারি। এটার আনসার কি? ওই যে ফার্স্ট পারসনের বেশি এনার্জি, কেন? কারণ ও কম সময় নিছে, তাড়াতাড়ি কাজ করে ফেলছে, তাই দেখতে এনার্জি বেশি মনে হয়। কিন্তু ঘটনা এরকম না, ঠিক আছে? ঘটনা হচ্ছে কি যে if they did same amount of work, then we can say that they both have same amount of energy. Khalas. Okay, we will not take a look at how much time he took. Time will come into consideration when we are talking about power only. Okay, because power is what divided by time. Okay, let me get finished with energy first, then we will talk about power. Now energy, mainly there are several types of energy out there. Okay, mechanical energy, then chemical energy, um, electrical energy, light energy, sound energy, heat energy, nuclear energy. So many types of energy are there. Okay, but mainly here we will be discussing about the mechanical energy. Okay, now this mechanical energy has two subcategory. Okay, what are them? Tamjid?
Yes, sir.
আচ্ছা, তাহলে বলো মেকানিক্যাল এনার্জি দুই টাইপের কি কি?
স্যার মনে নাই, করতে হবে।
কি বলো
Potential energy, kinetic energy.
রশিদ?
Yes, sir.
বলো দুই টাইপের মেকানিক্যাল এনার্জি কি কি?
Potential and kinetic.
আচ্ছা,
ওকে স্যার, মনে পড়ছে।
পটেনশিয়াল এনার্জি আর কাইনেটিক এনার্জি। গত 2 বছর ধরে কতবার পড়লাম আমরা এটা, হ্যাঁ? জীবনটাই পটেনশিয়াল আর কাইনেটিক হয়ে গেছিল। যাই হোক, তো এটা আমি জানি, অনেকেই জানে যে পটেনশিয়াল আর কাইনেটিক এনার্জি আমরা স্টাডি করি, বাট এই দুইটা যে মেকানিক্যাল এনার্জি এটা বলার পরেও কেন জানি তোমাদের মনে থাকে না। কারণ এটার পরে ফার্দার আমরা আসলে ডিসকাস করি না এজন্য। Anyway, so energy, several types of energy are there. We will focus on mechanical energy, and mechanical energy can be divided into potential energy and kinetic energy. Now, when can we say that a body has potential energy, and when we can say that a body has kinetic energy? Okay, these are the two questions. A body is on the ground, it is not moving, the velocity is 0. This body does not have mechanical energy, any mechanical energy. It means it does not have potential energy, it does not have kinetic energy. Okay, now if we lift up the body to a certain point, so what will happen? Definitely we lifted it up, we did some work. When you do some work, you lose some energy, obviously. Okay, you do some work, you lose some energy. Now, from the law of conservation of energy, we know that energy can neither be destroyed nor be created. It can only be transformed from one form to another. Okay, so এখানে খেয়াল করে দেখো, এই যে বডিটা এখানে উপরে আমরা উঠাইলাম, আমাদের বডি থেকে কিছু এনার্জি লস হইলো, এই এনার্জিটা ডিস্ট্রয় হয়নি। অ্যাকর্ডিং টু দ্য ল অফ কনজারভেশন অফ এনার্জি, দিস এনার্জি হ্যাজ নট বিন ডিস্ট্রয়েড, ইট হ্যাজ অনলি বিন ট্রান্সফর্মড from one form to another. So in our body, when the energy was in our body, it was mechanical energy, and when it got transferred into uh, this body, okay, it is potential energy. Okay, so this energy will be stored in this body as potential energy. So now let us say we lifted this body to this point. Okay, and this body is static over here, so we can say that the energy that is over here that is stored in the body is potential energy, because the body is not moving. This is the condition. Now, if we leave the body, what is the kinetic energy? As the body was static, it doesn't have any velocity, it was not moving, it was at rest. So we can say that it has zero kinetic energy. Now, if I leave it, what will happen? It will start falling down, right? Now, some kinetic energy we will notice. Okay? Cannot report the kinetic energy that because we will see that the body is moving. Whenever a certain body is moving, it has kinetic energy. Okay? Due to having kinetic energy, it will be able to move. So from where this kinetic energy is coming? Now you are not giving this kinetic energy anymore. Then from where it is coming? The stored potential energy is now being converted into kinetic energy. You know that energy can neither be created nor be destroyed. It can only be transformed from one form to another. So here what is happening?
Sir?
The potential energy is being, yes.
So your voice is so like it's having some problem. The voice
Sir,
is not so Jim.
এখানে কি লিখছে low system resources may affect your audio quality using some application to improve performance ও আচ্ছা ওকে দাঁড়াও আমি আমার ল্যাপটপে কিছু জিনিস ওপেন আছে মনে হয় সেটার জন্য এই ল্যাপটপটা বেসিক্যালি কি নামে ছিল জাস্ট স্কুলের ডকুমেন্টেশনের কাজ করার জন্য তোমাদের কোশ্চেন বানানো তারপরে ইয়ারলি প্ল্যান সিলেবাস পোর্শন এগুলো বানানোর জন্য কিন্তু এখন করোনা সিচুয়েশন হওয়ার পর থেকে ল্যাপটপের উপর অনেক বেশি প্রেশার পড়ে যাচ্ছে এসব এখনো ক্লিয়ার দেখা যাচ্ছে না আমি দেখতে পাচ্ছি ভিডিওতে ক্লিয়ার দেখানো বন্ধ করে দিয়েছি জুম ছাড়া বাকি সব বন্ধ হয়ে গেছে ক্যান ইউ হিয়ার মি নাও
Yes, sir.
আমি তোমাদের কথা ক্লিয়ারলি শুনতে পাচ্ছি না এই যে ভেঙে ভেঙে আসতেছে what can we do দাঁড়াও ভিডিওটা একটু পজ দিই
Energy transformation, something like that.
right energy transformation so as the body will fall down what will happen the potential energy will start converting to kinetic energy okay so as potential energy is being converting amount of potential energy will be decreasing and what will happen the amount of kinetic energy will be increasing okay so the body will fall on the ground and throughout the process when just before touching the ground the full amount of potential energy will be converted to kinetic energy okay so from here we can say something very important that is potential energy at the highest point is equal to the kinetic energy just before touching the ground okay remember this one Acha. After that let us talk about oh actually I didn't speak about the expression how to calculate potential energy and kinetic energy so we know that whenever we are lifting a certain body to a certain height okay some potential energy will be stored in it now this potential energy is equal to the work done by me okay আমি যতটুকু কাজ করছি ততটুকু এনার্জি ট্রান্সফার হবে এবং যতটুকু এনার্জি ট্রান্সফার হবে ততটুকু potential energy জমা হবে so indirectly we can say that the potential energy is equal to the work done by me now work is equal to force into displacement force into displacement let us say I have lifted it to a height of h now what is the force that you have to apply to lift a certain body that is equal to the weight of the body so that is mg into h so ep is equal to mgh very important okay and then kinetic energy of a body how we can calculate it the expression to calculate kinetic energy is half mv square okay there is proof of this one also but proof is not required anymore we are revising the chapter so we will only take a look at the expression itself okay so here you need the mass you need the value of g you need the value of height okay at what height you are taking the body so remember this is not covered distance this is the height from the ground okay in some equation h is also used as the covered distance so you have to know okay let me mention it here itself okay there are four equations of motion right when you write it for falling bodies you replace s by h let us say s equal to ut plus half at square this is an equation of motion for body for a body in motion but if you are applying it for a falling body then you replace s by h you write h is equal to ut plus half gt square acceleration is replaced by g so here the h means the covered distance from the height it is falling okay so 1 meter 2 meter 3 meter how much it is covering from the top from the highest position that is h over there that in that equation but here whenever we are calculating potential energy h represents the height from the ground remember all this okay and here mass is m and v is the velocity at any point you want to calculate the kinetic energy, you must know what is the velocity of the body at that point. Okay, that is v. Okay. About v square, I want to say something. Sometimes it will be confusing that you will be in need of the value of v square, but you don't have it. Okay, in the numerical problem, such situation will arise. So at that point, what you need to do? You need to apply the fourth equation of motion. V square is equal to u square plus 2gh. Okay, you have to apply this equation. In this equation, it is very important to remember that the initial velocity, we put it as 0. When the body is falling, not going up, remember, when it is falling from a certain height, we consider that it was at rest at some point, then it was left and it just started falling. So the initial velocity from which it started falling is 0. Okay, so it 0 square plus 2gh. So for a falling body, we can actually replace v square by 2gh. Okay, for a falling body, we can replace v square by 2g. So if you don't know the value of v, but you know that from which height it is falling, so you can calculate the value of v square. Always remember, this will help you a great deal, inshallah. Okay, so this is kinetic energy and potential energy. um, then we have power, right? So I already said that whenever we are considering power, we have to consider time. How much time a person is taking. Not only the amount of work matters, the time taken to do the work also matters. So that is why power P is equal to actually W divided by P. Okay, so if I say that someone did 10 joule of work in 5 seconds, so that means the power of that person will be 10 divided by 5 is equal to 2. 10 is joule, 5 is second, so joule per second. That means in every second he is doing 2 joule of work. Okay, per second 2 joule. In 1 second he is doing 2 joule. Okay, Acha. So this joule per second, this is the unit of power, but this one is also expressed as watt. W A double T. Okay, watt, and it is in short written as W. So 1 watt is equal to 1 joule per second. 1 watt is equal to 1 joule per second. I will write it here. 1 watt is equal to 1 joule per second. So if I ask you what is 20 watt, you can write 20 watt means 20 joule per second. That means in every second, someone is doing 20 joule of work. Okay, this is the significance. Might come for 2 marks. That what is the significance of 20 joule, 20 watt, or they might ask you, what do you understand by 20 watt? You can write that 20 watt means 20 joule per second. It means if a person is doing 20 joule of work in 1 second, okay, then we can say that the person has a power of 20 watt. Is it clear?
Yes, sir.
The last topic that we have in this chapter is efficiency. Efficiency, huh? So efficiency is eta is equal to output energy or power divided by input energy or power. And if you want to express it into percentage, then you have to multiply 100. Okay? So okay. So what you need to do mostly is solve creative as much as possible. Okay. So solve the creatives wherever you find. Actually, a great source I can mention that is from Teaching BD. Okay, also I gave you a suggestion book. From there also, if you solve all the problems of the suggestion book, inshallah it's safe. Okay, if you understand all those problems, then you can say that you are in the safe zone. Okay, so in the next class I will be expecting doubts from you in case of higher math from 9.1 exercise, and in physics from the suggestion book of work power energy. Is it okay? Understood? What is your homework?
Yes, sir.
Okay, so get busy. Okay, get homework for each and every subject. Get yourself busy. This is the opportunity of a lifetime. Only 4 chapters, A plus. Okay, okay. So see you in the next week, inshallah. Okay. And in case of any assistance needed, you can contact me through WhatsApp. Inshallah, I will try to reply as early as possible and as much as possible. Okay. Anybody wants to ask any question before we end today's session?
No, sir.
Okay. Nobody? Okay.